The learning goal for this lesson is to complete the area model in factoring problems. Complete the area model in factoring problems. So, in example 13, we're going to multiply the quadratic term and the constant term in the area model, and then multiply the two linear terms in the area model. Remember that the quadratic term has the x squared term, while the linear term has only an x. So, for the quadratic times the constant, 20x squared times 14 gives us 280x squared, and 8x times 35x also gives us 280x squared. Now go ahead and pause the video and try B, C, and D on your own. So, what pattern did you see in example 13? What I noticed was that the product of the quadratic term and the constant term is equal to the product of the two linear terms. And here's a proof to show you how it works. What we have here is the same area model we've always been doing, except we replaced everything with variables. So ax times cx is simply acx squared. And cx times b is simply bcx. And similarly, ax times d would be adx, and b times d is bd. And if we do what we did before, where we multiply the quadratic term and the constant term, these go to abcdx squared. And for the two linear terms, adx times bcx also gives us abcdx squared after we do some rearranging due to the commutative property of multiplication. So as you can see here, regardless of what the numbers are, with generic variables, we can show that the product of the quadratic term and the constant term is always equal to the product of the two linear terms. And also remember that you always need to check to make sure the two linear terms add up correctly. Pause the video and discuss this idea with your neighbor. So in this next example, we're going to complete the area model for 12p squared minus 28p plus 15. And you'll notice that they gave us no information about the factors, but they went ahead and placed 12p squared and 15 in the area model. If you remember from the previous example, we know that the product of the quadratic term and the constant term is the same as the product of the two linear terms. So that is some information that we have about our two linear terms that are missing from the area model. We also know that the two linear terms are going to add to negative 28p. So we have to do a little bit of hunting, where the two numbers are going to multiply to 12p squared times 15, which is equal to 180p squared. Or if we prime factorize, we have 2 times 2 times 3 times 3 times 5p squared. And they're going to add to negative 28p. So let's go ahead and find every combination of integers that multiplies to 180p squared. So let's start with 1. 1 times 1p times 2 times 2 times 3 times 3 times 5p is going to give us 180p squared. And then next we have 2p multiplied by 2 times 3 times 3 times 5p is going to give us 180p squared, because the 2 uses up one of the 2's from the prime factorization. Next we have 3p, which uses up a 3, so we have 2 times 2 times 3 times 5p. And then we have 4p, which uses two 2's, which gives us 3 times 3 times 5p remaining. So let's go ahead and check to see if it's working. So as always, we have 2 times 5 is 10, 2 times 3 is 6, times 3 is 18, times our 10 is 180p, so that works out. And then 2 times 5 is 10, times 3, which is 90, times 2 is 180p squared. And then we have 2 times 2 is 4, times 5 is 20, times 3 is 60, times 3 is 180. And 3 times 3 is 9, times 5 is 45, times 4 is 180p squared. So we can be sure that what we're doing is correct. So let's move on. Next up is 5p. Uses up this 5 from the end. So what's remaining is 2 times 2 times 3 times 3p. And then we have 6p, which uses a 2 and a 3. So we have 2 times 3 times 5p. And 7, well, there's no 7 inside our prime factorization, so I don't think it's necessary to include 7 within this process. And 8 similarly as well, because 8 requires 3 2's, and we only have 2 2's, so there's no reason to include 8 either. So next up we have 9p, which uses 2 3's from our prime factorization, so we have 2 times 2 times 5p. And then for 10, we have, it uses a 2 and a 5, so we have 2 times 3 times 3p. And then we have 12p, which uses a 2, and a 3, so we have 3 times 5 times p remaining. 13 is not in our prime factorization, so we don't need to include it. 14 has a 7, and 7 is not in our prime factorization, so that's not necessary either. So next up is 15p, which uses a 3 and a 5, so we have 2 times 2 times 3p remaining. But however, we notice that 3 times 5 is 15p, and 2 times 2 times 3 is 12p, so these two cases are actually just reflections of each other. And if we continue going down, we're eventually going to hit all of these numbers again. So there is no reason to do that because we have the commutative property of multiplication. So now we have concluded our list of possible factors of 180p squared. So now we need to add to negative 28p. So go ahead and pause the video and discuss how I came up with this list of every possible factor. So I wrote ahead and evaluated all of these prime factorizations of our factors, and so for easy adding. And then we also have to be careful of another thing. Both of our numbers multiply to positive 180p squared, but they add to negative 28p, which implies that both of our factors are negative because two negative numbers multiply to a positive number. So I'm going to go ahead and add a negative sign to all of our factors here. So let's get adding. First, let's add negative 1p and negative 180p to get negative 181p, which is not negative 28p, so this is obviously not our pair. And negative 2p with negative 90p gives us negative 92p. Negative 3p and negative 60p add to negative 63p. And you'll notice that they all go down, so I'm just going to skip along a little. And we're just going to add negative 10p and negative 18p to get negative 28p, which is what we were looking for in the beginning, which implies that our two linear terms are going to be negative 10p and negative 18p. So let's go ahead and add these to our area model, where we can just put negative 10p here and negative 18p here, and we have successfully completed the example. Now go ahead and pause the video and discuss what happened here with your neighbor. Remember that we can be sure that our answer is correct because if we multiply our two linear terms, we get 180p squared. And if we multiply 12p squared and 15, we we also get 180p squared. We can also add negative 10p and negative 18p to get our negative 28p that was in the original equation. Let's try another one. In this example, we're going to complete the area model for 8m squared plus 6m minus 27. So I'm going to go ahead and write in 8m squared here and negative 27 here. And for our two linear terms, we know that they multiply to 8 times negative 27 m squared. And what this tells us, and we can prime factorize first as well, so we have 2 times 2 times 2 times 3 times 3 times 3 times m squared. And then we can make our nifty little table here. And we also know that the two numbers are going to add to 6m. So let's begin the hunt for our factors. Let's start with 1. And 1 is going to multiply with 2 times 2 times 2 times 3 times 3 times 3m. And then we have 2m, which is going to multiply with 2 times 2 times 3 times 3 times 3m. And then 3m is going to multiply with 2 times 2 times 2 times 3 times 3m. And then 4m multiply with 2 times 3 times 3 times 3m. Alright, and then 5m doesn't exist because there's no 5 in the initial prime factorization. So we're going to go to 6 next, where it uses a 2 and a 3. So we have 2 times 2 times 3 times 3m. And then 7 doesn't exist. And the rest of them, I'm going to have you do yourself. But remember, when you can identify that you can stop finding factors, it'll be when you see a repeat in two terms. Now go ahead and pause the video and try it on your own. Alright, so here's what I came up with. And hopefully you stopped after 18 because you noticed that 12m times 18m is the same as 18m times 12m. So now we have to determine which of these factors add to 6m. So let's look at this for a second here. The two linear factors are going to multiply to a negative number, which means that one of them is going to be positive and one of them is going to be negative. And because they add to positive 6m, the one that is positive will always be the one that is larger in magnitude. So let's check it out here. We have 1m and 216m, and because 216 is greater than 1, we know that it is negative 1 and 216. But these add to 215m anyway, which means that 1 is not correct. And if we go to 2m, 108 is larger than 2m, so 108 is positive and 2 is negative, which means that 108 minus 2 is 106. And then let's do 3. 72 is larger than 3, so 72 is positive and 3 is negative. So 72 minus 3 is 69m. And it's going to keep getting smaller, so let's keep going down until we get over here, where we have 18 and 12. And then we notice that 18 is larger than 12, so we'll give 18 the plus and 12 the minus. And 18 minus 12 is 6m. And just if you wanted to do this case, 12 is smaller than 18, so we give 12 the minus and 18 the plus, and they still add to 6m. So lucky for us, we have determined that the two linear pairs are negative 12m and 18m. And then we can add them to our area model. So we put a negative 12m here and an 18m here. And we have successfully completed the example. And go ahead and pause the video and check with your neighbor about what we did here. Here's one for you to try. Complete the area model for 6x squared minus 23x plus 20. And be sure to do this one with your neighbor because it's pretty tricky and I don't want you making any silly mistakes. So go ahead and pause the video and give it a try. Okay, let's see how you did. So first I got the prime factorization of 120x squared to be 2 times 2 times 2 times 3 times 5x squared, because I know that the two linear factors are going to multiply to 120x squared. So then I listed them all out, and then I stopped at 12 because 10 times 12 is the same as 12 times 10. So then what I did was I added all of these factors to get our values, and I found that the one that was negative 23x was negative 8 and negative 15x. So then I knew that our two factors were going to be negative 8x and negative 15x, and I put them inside the area model. Now go ahead and pause the video and discuss what I did here. Okay, let's see how you did. So first off, I multiplied 6 and 20 to get 120x squared, and that's our prime factorization here, 2 times 2 times 2 times 3 times 5x squared. And then I noticed that our sum for the two linear terms was going to be negative 23x, and because our sum is negative and our product is positive, I knew that both of our terms had to be negative, so I went ahead and added negative signs to every single part of this prime factorization. And then I stopped at 12 because I noticed that negative 10x times negative 12x was the same as negative 12x times negative 10x. And then I added all of these together, and the one that turned out to be good was negative 23x, or negative 8x times negative 15x. So those had to be our two linear terms, so I put them inside the area model. Alright, so here's another one for you to try. Complete the area model for 35w squared minus 53w minus 18. Now go ahead and pause the video and try this one with your neighbor. Okay, let's see how you did. So first off, I multiplied 35 and negative 18 to get negative 630w squared. And then I prime factorized that to 2 times 3 times 3 times 5 times 7w squared. And then I wrote out all of the possible factors here. And you'll notice I didn't bother evaluating the prime factorizations until I hit around 6 or so, because they need to add to negative 53, so they have to be kind of close. So then I kept going, and I stopped around 21 or 30 because I noticed that 21 times 30 is the same as 30 times 21. So then next I had to account for the addition part. So they have to add to negative 53 while also multiplying to a negative number. And because they multiplied to a negative number, one of them has to be positive and one of the other linear terms has to be negative. So the negative linear term has to have a larger magnitude. So I gave a negative sign to all of the ones that were larger in magnitude. And then I added, and then I came to negative 53w, which was the pair of 10w and negative 63w. So I put them inside the area model. Okay, here's one more for you to try. Complete the area model for 9x squared plus 0x minus 64. And try this one with your neighbor. Okay, so here's what I came up with. So first I multiplied 9 by negative 64 to get negative 144x squared. And I prime factorized that to negative 2 times 2 times 2 times 2 times 3 times 3. And then I also noticed that they add to 0x here, so I wrote the 0 there. So then what I did is that because the product was negative, I knew that one of them had to be positive and one of them had to be negative. And also, because the sum was 0, I knew that because one of them is positive, one of them is negative, they both have to have the same magnitude. So I went through and looked at these and saw that one of them was 12 squared. So one of them is going to be positive 12 and the other one's going to be negative 12, so that they can add to 0. So our two linear terms are going to be 12x and negative 12x. But you might have also noticed that this is a case of difference of squares, and we don't even need the 0x here, because 3x squared is 9x squared, and 8 squared is 64. As we finish the lesson, remember that our learning goal was to complete the area model in factoring problems. And here are some wrap-up questions. What was the pattern that you saw when multiplying the parts of the area model? Why is this pattern useful in the process of filling in the area model? How do you know if the linear terms should both be positive, both be negative, or one of each? How do you know that you have found the correct pair of linear terms to fill in the area model? In a difference of squares model, what do the linear terms look like?